Hello, hi Herb. This is going to be some chill maths on a Sunday afternoon. I'm James. Hi. Never know if I'm supposed to do an intro. Doing an intro is for YouTube, right? But I guess these go on YouTube at some point. So if you're watching on YouTube, then hello, this is still the intro. You might want to skip it so that we can get to the bit where I start playing the natural number game again. How's everyone doing? You all right? Twitch says there's some. Oh, cool's here as well. Hello, cool. I was going to say Twitch says there's people. In that way, Twitch has got this kind of really tiny bit that says, there's some people watching your stream. And it's got a very large run adverts button, which is always very tempting. I hope everyone's having a good weekend. Sorry if I sound a bit ill or if I look a bit ill. It's because I'm a bit ill. I met lots of, we do maths at the weekends in the department. I met a lot of people and might be ill. Hi, Mary. I hope everyone else is doing great. January, yo. Would abolish January, I think, if I was in charge of time itself. So I thought we'd do the natural number game again. Previously on the stream, we spent about 2 hours doing this stuff. Hi, Asher. Down this side, and there's a whole bunch of stuff that actually sounds quite exciting, like Advanced Edition, which I'd like to get to. Hi, Neutrino. Stream's interactive, of course, part of the fun. I found out last time I'm not great. Well, I got really stuck on some levels, and chat had to help me quite a lot. So I'm sort of hoping that happens again. Let's find out. Hello, Thrushy. Guess I have people here. I like that Pikachu emote. How do I do that? Oh, hang on. Right, so is it a candle? Okay. Is that from someone? Okay. Today on James Learns Twitch, how do I do that? How do I get the Pokemon? If I want, can I just type it? If I go emotes, search. I can do it as well. Brilliant. Right. Okay. I've learned a Twitch thing. But you have to know what it's called. Oh, the search feature is. I know some of these Pokemon. Right, good, okay, fun. Cool technology. Thanks, Badger. Right, okay, I think I'm going to jump into Implication World. I haven't done it before. This is what I found out is this is what's called an actual play. Actual play, not scripted. And we're going to try and do things. We've just done the addition world and the tutorial, which did 2 + 2 is 4. We're going to learn how to prove that 2 + 2 is not 5. I kind of do love this. Love this kind of foundational approach to mathematics, but also, if you prove that 2 + 2 is 4, we're now going to, I think, use the whole world to prove that 2 + 2 is not 5. We're going to learn about that symbol, I suppose. As always, the text on the left is the helpful stuff. If you're wondering what's going on, there's usually some helpful text over here. I'm going to be solving a level that appears here, and there's some tactics that I can use over here or by typing. That's what I remember from 2 weeks ago. Implications. Okay. Oh, this is good. This feels like solving equations. I like this a lot. Solve x + 1 is... Go from x + 1 = 4 to x = 3. 2 new fundamental facts about natural numbers. Oh, okay, right, good. Look out for 2 new axioms. Okay, things like P implies Q. How to prove a theorem of the form P plus Q. If P is true, then Q is true. Oh, okay. Need to learn some more tactics. The exact tactic can be used to close a goal, which is exactly one of the hypotheses. It's new, it's in yellow. That sounds like RFL. We did a lot of RFL 2 weeks ago for both sides of this equality are true. I guess that's about equalities. Okay. Exactly one of the hypotheses. Okay, wait, what? So our goal is x + y is 37. Our assumptions... Wait. Right, so if I read this thing on screen, assuming blah and a different thing, we have blah. And that's one of the things that we were assuming. Okay, so I have to type exact because I'm using that is exactly one of the assumptions, and I have to say which one. Right, so I do feel the tutorial elements of this are a little bit maths. Solve this level by typing EXACT space H1. Confetti, we did it. Okay, so we're using this goal statement. The thing we're trying to prove is exactly one of the assumptions. There's another random assumption that we don't have to worry about. Okay. If it's not exactly, we're going to use rewrites. Okay, which we use RW for, I guess. So we've got an assumption. Assuming this, we have x is y plus 2, and there's some maybe commutativity, the brackets around here, or some associativity going on. Rewrite 0 add h. I think I can remember how to do this. So do we? Oh, we rewrite it at h to change h into the goal. We've done a lot of rewriting of the form rewrite the goal, but this is telling us to rewrite h instead, which I don't think I've done yet. Oh my goodness! Yeah, you type at h if you want to change it in the hypothesis, which kind of feels dangerous, but never mind. Okay, so I'm going to repeat its rewrites. I remember that was a speedy way of doing. Repeat is a speedy way of getting multiple things to happen. That's a little bit low off the screen for you, isn't it? Let's just put it there. Okay. Repeat 0 add at h. So happy with that? Yes, happy with that. And now the assumption has changed. We've used this rule about adding 0 to simplify the assumption, not to modify the assumption, rewrite the assumption, but now it matches. So now I type that's exactly h. Yes. Okay. Great. We're doing it, chat. We're doing it. I sometimes tell people that the cool thing about maths is you get to build non-trivial things out of trivial things. The tutorial elements of this sometimes feel like you're building trivial things out of trivial things, but I guess we're starting somewhere. One of the hypotheses is an implication shown with this little arrow in here. X is 7 implies y equals 42 via kind of like mystic knowledge or something. It's not really like human. When a human says if x is 37 then y is 42, they've usually got a reason. Right, we're going to use the apply tactic. So this takes apply. You apply something of an. What is the syntax for this? Oh my goodness. If T is a proof that P implies Q, or maybe just an assumption, I think assumptions count as proofs, then H is a proof of P, then the syntax works like this. Apply T at H. Apply the implication at thing on the left. So I go apply. Because I'm doing it to H1? Let's find out. Apply H2 at H1. So I think that's now going to change H1 into a... Okay, it's listed them the other way around, which is fun. But yeah, it's changed H1. Look, before it was X equals 37, and now it says Y equals 42. Now I can type exact H1. Right, okay. So this feels dangerous because it feels like you can't go back because you can't reverse implications. Hi Zoe. How's it going? We're doing the implication world in the natural number game, which I've heard good things about. Apply is backwards and exact is forwards. Oh my goodness, that is too clever for me. I don't want to think about forwards and backwards. Exact I'm using if my goal is exactly the same as one of my assumptions. I think that's how I'm going to understand it. And apply I'm using to apply an implication to something like an assumption. I'm applying it at the assumption, changing the things forwards. I'm thinking of that as a kind of forwards progress to change this into H2. Oh, blimey! I'd forgotten about that. The game has help text in the following sense that you mouse over something and you get a wall of. Oh my goodness! Oh, I've moused over an equals sign. The most complicated of things. That's one introduction rule. Oh my goodness. We use it as notation for A, B. Oh my goodness. No. Don't tell me more. Right, it's time to learn about suck_inj. The successor function is injective. Oh, is this going to try and help us? Right, let's read the thing on the left. Right, okay. If A and B are numbers, then suck_inj. This is a little bit like subtraction, but not really. To say that suck A equals suck B. Neutrino, I think if I get to a multi-step one, I can't think about them in the abstract unless there's one on screen. We'll get there in a second, I think. We're going to prove this. Okay. Right now let's just assume it. Sometimes the help is very circular. Right now let's just assume it and let's prove this by using it. Okay, so we're going to see what it's for first and then do that. Okay. In a level about getting things in the right order, I feel like. Anyway, this would be more helpful the other way around. Whatever. Manipulate our hypothesis until it becomes the goal. It's so weird because the previous... I'm sure 2 weeks ago we didn't manipulate any hypotheses at all. We just manipulated goals, but never mind. I will walk you through this level. First, let's get H into the form suck X. We're going to need to use the fact that 4 is the successor of 3. Oh my goodness. Right, so I'm going to rewrite H, which you do like this. You rewrite using 4 as the... 4 is the number after 3. I'm a mathematician. You can trust me. And that changes this. So our assumption is now x plus 1 is the successor of 3. Are we going to do something to do this at x plus 1 as well? Oh, I'm going to use a left pointing arrow thing. I remember those. They were really complicated. Rewrite it the other way round. Oh no, I've missed this step. I'll rewrite suck egg add 1. I've forgotten that one. Do we have suck egg add 1? There. Backwards at H. I'm doing it. It's gone off the bottom of my screen. Okay, great news. Our assumption now says the successor of X is the successor of 3. Now let's apply our new theorem. Okay, maybe this does feel like backwards. Hi Zoe, I'm a bit under the weather as well. I think there's stuff going around. Yeah, woof. Brill. Sorry that you're feeling unwell as well. What on earth am I doing? Apply our new theorem. Oh, we've got suck_inj as a new theorem. If the successor of A and B. Right, see if I can remember how to do this without reading the thing. That's my hand blocking the screen. If you'd like to play along at home, put your hand over the help text. So the notation for using a theorem is something like you have an implication, which for us is the theorem, and you're supposed to use it at the thing that matches the left-hand side. And for us, it's that suck A equals suck B would imply that A equals B. So I want to apply, and then I have to type the name of the thing, inj, and I want to do that at H. Oh, it's not happy with me. Does apply doesn't have square brackets. It's like learning all programming languages. Yeah, this is exactly H now. Exact H feels like the new RFL. When you've got it down to like, phew, finally, we're there, we did it. Exact H. Crikey. Okay, what are we doing? We've got a new theorem, which I sort of intuitively believe, and apparently is one of Peano's assumptions, but we're going to prove it in implication world. So I hope that's going to do that now. Yes, I would love to manipulate the goal in case it becomes the hypothesis. Oh, and this is when Neutrino is saying backwards in chat. How are we going to pronounce this one? Yeah, we were saying ruffle quite a lot last time. We said ruffle for our sort of celebration of RFL. exact for an exact h, exact. That's exactly the right thing. The apply tactic can do this too. I hope it's not using left arrows. If it starts using left arrows for... Oh, no, it can't. It can't. Right, we're in Neutrino's favourite world. I've got to keep going, right? X plus 1 is 4. Our goal is to say that X is 3. Start with apply suck inch to apply suck inch to the goal. The goal doesn't have any. I bet this doesn't work. Oh no. Why did that happen? Oh, why did that happen? Oh! Wait, Neutrino, which one did you say was forwards and backwards? Right, yeah, this feels very backwards. Apply is backwards. Got it, okay. If you do the things... Right, okay. If you just apply... If you apply it up there to the assumptions or something, all bets are off. I don't know what you're doing. If you apply it backwards... So this is saying, if we could prove suck x equals suck 3, it's like arguing backwards. If we could prove that suck x is suck 3, then we could... This would be the last step in our argument. Yeah, so then we'd end up at x is 3. So it's like... Oh, it's not quite assuming the converse, but it changes the right-hand side of the implication into the left-hand side of the implication, ready for us to prove, moving the goalposts. I love how this left-hand side is like, you shouldn't teach your granny to suck eggs. Bizarre to me. Right, okay, what are we doing? I think we're now going to rewrite the assumption using... yeah, well, no, sorry, it says on the left, doesn't it? But we're going to rewrite using suck x as 1 or something at h. If I spelled that wrong. Yeah, I've spelled that wrong. We had a theorem about this. Oh, no. No, I'm just being bad at this. Oh, I've got to rewrite it leftwards. There we go. There we go. And then rewrite 4 is the number after 3 at h. And now that's exactly 8. I can't. It's exactly h. Right, good. Many people find apply t at h easy, but some people find apply t confusing. If you find it confusing, then just argue forwards. I think that's me. I think that is me. I feel seen. You can read more about the apply tactic in its documentation. Great. Cool. I find the documentation quite tricky. Hello, Super Snowman. We're doing natural number game again. Seen how to apply theorems and assumptions of the form P implies Q, but what if our goal is of the form P implies Q? To prove this goal, we need to know how to say, let's assume P and deduce Q in lean. We do this with the intro tactic, which at the moment feels like a random name, but let's go. Is this... this feels like the same syntax as the induction thing. I guess what I'm expecting is that this will break it down into a kind of separate goal or something. Intro H. Assume the hypothesis and call its proof H. Now, because these both sides are the same, I haven't really been able to see what it does. Not great learning experience, but hey, that's exactly H. Right, hopefully the next level will break that down. So that when you intro... Try this one by yourself. So when you introduce a hypothesis, right, your hypothesis is that the left-hand side is true, and then it's time to prove the right-hand side, which I think... do we have an addition thing about this, or am I just going to repeatedly use? Our goal is x equals y, and we're assuming that x plus 1 equals y plus 1. I think I want to rewrite the hypothesis using the successor thing is adding the same thing as adding 1. Oh, come on, leftwards. So that my assumption... Oh, do it again. both sides, please. I'm trying to change those +1 symbols in H into successor functions. And now this looks like I should do... Oh, big test. Can I apply... I've forgotten what it's called, but the thing about successors of numbers is suck-inj. Yeah. Yeah. Here's a completely backwards proof. Apply suck-inj. Oh, there! Repeatedly do that. Oh my goodness, but forwards. Oh, I don't know about that. Let's try that out. So if I just intro H, then they're saying I can do apply, so backwards, change the goal. Change the goal like that, and then change the goal by using the forwards version. Okay, I can kind of see that this is nice. Okay. So you can work sort of forwards or backwards for your proofs. Fine. Still can't prove that 2 + 2 is not 5 because we've not talked about the definition of not equal to. If A equals B, then false. Okay, we haven't seen false yet, so... I haven't seen truth yet, right? We haven't seen anything true or false. Expulso? Is that a Harry Potter thing? Wait, I gotta look that up. What? Oh, it's Latin. That's why I think it's. We're not quite at the expulso. It'll happen. Oh right, okay. Spoilers for the goal. False is an interesting thing to see on screen in the natural number game. Even though A does not equal to B does not look like an implication, you should treat it as an implication. Next two levels will show you how. You cannot deduce from a consistent set of assumptions. If your goal is false, you better hope that your hypotheses are contradictory, which they are in this level. Great, okay. You gotta hope that your active goals are actually correct. Otherwise, we'll be playing this game forever. H2 is a proof of x equals y implies false. Try applying H2 either at or H1 or directly to the go. How could you apply? Oh, right. So we've got to specify what we're applying. So and then that's exactly H1. Okay. So we've got things with the form P implies Q, and we're trying to daisy chain them together. We can work from the end of the chain using apply, or we can work from the front, rewriting our assumptions. I don't really like rewriting the assumptions because you have to say at H a lot. The default is to rewrite the goal, so that's slightly nicer. If we're going for the speed run, we want to do less typing. Okay. Warm up for 2 + 2 is not 5. Let's prove that 0 is not 1. Wait, but we're going to introduce an axiom. 0 neither suck n. Proof that 0 is not the successor of any number n? To learn about this result, click on it in the lever on the right hand side. Okay. Right, we're going to introduce a hypothesis apparently. Could I instead apply... They're telling me to start with the intro. I want to see what happens if I just apply the... Ha! What was I supposed to be doing? Give me one axiom and one thing to do, and the correct thing is to apply it. Oh, okay, well, let's introduce a hypothesis. Do it properly. And then we're going to change the 1 into a successor of 0. Yeah, I've heard it called total collapse as well, which it's fun. I've heard that in fields as well. People don't want their fields to have one element. And then I saw a very good talk once that was extremely confusing, but talked about properties that the field with one element might have, and how it compares to other sorts of mathematics, maybe is a good way. It was a very good talk that I didn't understand at all. Right, this is a long way round. We're now assuming that 0 is 1 and we're trying to prove false. So I guess time to prove. Rewrite. Rewrite. We're going to use the 1 the successor of 0 at h. It's going to rewrite it. And now can we just use, well, now it's going to let us use, so not the successor of any number at h. So it's going to apply, we've got the left hand side, it's going to give us h is now false. Yeah. Good. Okay, we've done a good split here because 2 weeks ago we played this game and we had to type ruffle quite a lot. Now we're playing, we seem to be getting ones with exact at the end. So that's nice. Okay. The sim tactic. Hang on a minute. Whoa. We haven't used this yet. Equality is symmetric. Sim with 2 m's. Changes the goal. Matters for the speedrun. Y equals x. I miss ruffle as well. Should we do some ruffle just in case? Oh, ruffle failed. What if we have a hypothesis such as that way? It's the wrong way around. Sim changes it, and sim at h does the same for the hypothesis. We've proved that 0 is not 1. Oh, is that called 0 nay 1? Nay 1 is 0 0 is an upcoming locked content. One day we will be able to prove whether or not it is 0 0. Maths. Oh, yeah, that's true, Zoe. Except for some medicine lectures, where for legally, it's particular sorts of medicine. In practice, people don't have a lot of spare time for going to other lectures, but yeah, you can't take the exams, but you can just pop into anything that's going on. What am I doing? I can't see the proof of 0 ni 1. Oh, maybe it's in here. No, that's this. I've seen 0 ni suck. Where would I look for 0 ni 1? Oh, there it is in the numbers. 0 ni 1. Good. Okay. But that's left to right, so we need to use sim and then apply. Is it an apply? Yeah, because it's an implication, right? 0 ni 1. Yeah. Now, what did that apply do? So if my statement, if the thing I'm aiming for is an expression or a statement, then I need to do some exact h at some point. I think I'll have a hypothesis and it will match. And whereas here, apply on its own, and on the previous level as well, apply seems a little bit powerful. That the statement is an equality. We're not sort of comparing it to that with a ruffle or something. Yeah, 0 ni 1. What is this? It's a proof that 0 is not 1. Oh, okay. It's not a. Sorry, it's being stored. It's down here. It's being stored as a theorem. It is a proof in itself. We're applying a theorem rather than with these. Oh, so these are proofs of equality, whereas this one's a proof of. This one's a proof of. I'm getting there. Some of these are proofs of equality, and this one is a proof of an implication. So it's a little bit different. When I apply it, it feels a little bit different in the game. Okay. There was a bit of content there that I didn't read. If I'm going to do it again? Oh no. Okay. What do you think of this 2-liner? Exact 0 ni 1. Ooh, that's nice. What do I think of it? I think that explains what's going on where I was just confused just now. this is exactly. So instead of exact, yeah, okay. So I was expecting an exact at the end, but this is doing a comparison. Got it. Thanks, Neutrino. Having just said we're doing a lot of riffle. In the previous one, and a lot of exact this week, I was expecting exact to come up. And there it is. You can exactly do a thing. Right. 2 + 2 is not 5. It's boring. Unfolded all of the numerals for you. Ugh. Here they are. This level sucks. Right, I've got to use 0 and E suck and suck inch to prove this. But I also want to do some stuff to just rearrange these successors, right? I can't quite remember how that worked in the addition world, but I kind of want to stack together the sucks on the left, so that there's 4 of them, and on the right there's 5, and then do a whole bunch of suck being injective until I get down to one and none, and then say, aha! That's my big plan. Can't remember how to move them around. Quick look. It's this thing, isn't it? Yeah, let's use that. Let's repeatedly use this and see what happens. Huh. Let's do a repeated rewrite. I'm not sure it's actually repeating anything. 0 add, because it seems to have one of those in there. There we go, okay. That's kind of what I wanted. 4 on the left, 5 on the right, but it's cheating. And then a repeated, I guess I have to apply suck inj. Can I repeat that? No. Ooh, it's not happy. What am I doing? I've forgotten how to suck inj. Suck inj is a proof. Oh, I don't want to do this. I want to repeatedly do it at my... okay, maybe I want to intro H. Intro H is going to make it easier for me to understand what's going on, because then I can repeatedly rewrite using, repeatedly apply suck inj at H. Yeah, that simplified it down. So that repeatedly applied to H, the thing that says successive function is injective, so you can cross out a suck from both sides. And it did that repeatedly, and now we got down to this thing. So now we're going to see if we can get this right. I'd like to apply. Which way round is Nisark thing? 0 is not the successor of n. So if I apply 0 Nisark at H, then I get false, and that's exactly H. Okay, so I could probably have done that without... Oh no, they did an intro H. What did I do? There's this review button up here that I'm hitting quite a lot. Well, I guess it turns into this terminal view, which I don't enjoy as much, but whatever. Rewrite, add suck at 0. Yep, okay, I did some of that. Oh, they introduced H earlier than me. And then some suck inj. And then 0 and E suck. And then exact H. Yeah, pretty much. Okay. Even though Leavenworth is a theorem prover, right now it's pretty clear we've not developed enough material to make it an adequate calculator. In algorithm world, computer science, we'll have to do a vote at some point. Develop machinery which makes questions like this much easier. Okay, goals like 20 + 20 is not 41 feasible. But I was enjoying repeatedly applying. I think this would work for a lot of things. More mathematics in advanced addition world. Proof dilemmas needs to get a working theory of inequalities. Okay, chat. We've got a computer science-y sort of world. For machinery like this, algorithms, and we've got advanced addition. Yeah, I haven't tried Graph4 either. I saw you linked it with a suggestion. Do you want to suggest any good graphs? It's a game where you have to make graphs. I think a projectile moves along the graph, and it's like worms. That's what you said. Martinesh says the game is hard. Okay, we're gonna vote. I think. New poll. It's branch, and the options are advanced addition or algorithms. And you can have additional votes based on channel points. Because that feels sort of vaguely chaotic. In the old version, there are some levels in the algorithm world that make you think, oh wow, I'm stupid, and oh wow, this is cool at the same point. Oh, I don't know about new version, yeah. So I'm playing version 4. I think I previously tried version 3, didn't get very far with it at all. Let's look at this poll. Can I look at this poll? I also want to look at this graph that Super Snowman's put in. 1 over 1 plus x. Yeah. Yeah, this graph's very useful. This is 1 over 1 plus e to the x. It's a sigmoid kind of thing, right? So you could use this for, I don't know, shooting around corners or something. I think you could change, there's maybe a number you could stick in here if you want it sharper. And of course there's a number you could put up here if you want, oh no, what did I think that would do? What did I think that would do? I thought that would make it larger. Anyway. Oops. Equations for the derivative. Ooh, I don't know about that. I moved the wrong slider. Welcome back. In my defence, I'm not feeling very well. That's not a good defence. Oh yeah, I just moved the wrong slider. Ah, good. That means my maths intuition was fine. I got it back. That's what I wanted. I had some of these. These are sigmoid functions. They're really, really useful. You can use them for sort of switching things on, and it satisfies a nice differential equation. So it turns up in some places quite naturally. I think I had some in my PhD, but can't really remember. Thanks, Zoe. Oh, okay. So graph war is happening simultaneously. If you want to get in on a graph war, you can offset the slide. Oh. Looks like Algorithm World is winning in our poll for next one. I'm pleased we've got 3 Implication World. Lots to understand about apply there. Ooh! I will open random Desmos things. Yeah, that's nice. Shall I open random links on stream? Yeah, great idea. Desmos is not happy with you. Oh, it's so unhappy. Oh, it's sad. It's sad watching it try and fail on different places. Is this one with constant curvature or something? Or the one, no, constant rate of change of curvature? I've seen that there's a bunch of different things you can do. You've put broken Euler spider up here. It's really unhappy. Why is it so unhappy? I don't know what you're doing. Oh no, hang on. These -1 to the ends and the C's and S's make me think this is the real and imaginary parts of something where you've got a power series. Oh, I see, okay. Oh, so there's a number of terms in your series and the convergences. Why is it looks quite happy at the moment. Oh, but then suddenly at like 40 something it gets less happy. Oh wow, yeah, it's really unhappy about some of these. Oh gosh. That is sad. Oh, I don't like the way the kind of snowflakes disappear as you zoom in. It's really off-putting. I think it's supposed to spiral into a point though, isn't it? Anyway, right, good. I think we're doing Algorithm World. I think Algorithm World won the poll. I think. I wasn't really watching. How do I get it back? Okay, I'm pretty sure Algorithm was won. Sorry, chat. We're in here. Yes, okay, this speaks to me. Yes, this was really tedious. Oh, is this where we're going to learn the thing to do things quickly? Let's go, we've got 9 of these. Community associativity, yes please. Start by reminding you of this. No, it's another one. It's another one. Okay. Yeah, you have to specify the things you want to rewrite. We had so much pain with this a couple of weeks ago. Okay, rewrite. What do I even want to do? I think I want to rewrite using add a sock on AC. No, BAC. Oh my goodness. How does add a sock work? Dum 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 bum bum bum. Oh, I want to do it right to left, or maybe I want to do it to the left of this equation. Oh my goodness. That way around? That way around. What did I do? What did I do? Oh, this is tedious. Because I also want to rewrite this side where it's BAC. I missed that they both have brackets. RFL! Yeah, nice. Okay. That was horrible. A plus A plus 1 plus B plus B plus 1 is, oh my goodness, move all the B's around. Brackets, swapping variables, rubbish. So I think Graphall sets 0 to 0 so that your projectile starts your position, but I'm not sure. Graphall! Let's forget about the brackets and just think about the variable order. Yes, please, I would love to forget about brackets. We need to swap B and C and then swap B and D. Easier than you think with add left column. So repeatedly doing add a sock moves all the brackets to that side. Yeah, this is just explaining how to do one of the levels I liked the least. This one where we have to do loads of this. Left column, BC. And why did that work? Oh, okay. Yeah, we had this thing. Add left com is quite good, isn't it? This doesn't feel new yet. This feels like oh, why are you not happy? Oh no, I don't want to add left com. I want to add commutative. So we've got left com and add com. For left adding, this one. I think we had to prove it once, but the idea is once you've proved it, you've got it, and then you can use it in later ones. You ready, chat? That's the algorithm. What? Oh. Oh. But I had to do it. I thought the computer was going to do it. Oh, I would like some technology. Oh, right, okay, it's the squirrels thing. Apparently you're not allowed to say this on Twitch, so we're going to call it squirrels. I'm probably not allowed to say this on Twitch either. Right. Rewrite every lemma, and every lemma fed to it by the user tagged by that. Which is not a level that I want to prove by hand because look, the brackets are awful. Get the simplifier to solve it for you. Solve this level in one line with... This is the one where James finds out he's the computer. You mean what? You kids don't remember the robot episode. There was one where I turned out to be a robot. It was great fun. The audio broke really badly and made me sound like a robot. And then, not much later, somebody created... Anyway, there's an on-screen graphic for it. It was great fun. Before this show. Different show, I suppose. Continuity. I guess for continuity across the streams, I'm a robot in this world as well. Well, I mean, I'm going to type the thing in the help text on the left, but I would like to slightly understand it. So I guess the only is like restricting it because it probably this solves it. I mean, no progress. Only. There was a Desmos plot of my face at one point. I thought that was quite robotic as well, but that's students in third year now, I think. I wonder how they're doing. Okay, I mean, I typed the thing it taught me to type. This simp. The argument to this. The squirrel thing. That include an RFL. Rewrite every leg tagged by it and every lever fed to it by the user as much as it can. Attempt to order the variables into an internal order so it does not go into an infinite loop. We've done an infinite loop before. Okay, this seems to be robbing me of the joy of doing an RFL. So mixed feelings. Okay, so I was supplying it with some rules. I reckon this level can be done with just these things, and then we tell the squirrels to go and do it. Now I can imagine that the algorithm is powered by squirrels. Wait, there's a variant? Make your own tactics in lead. Uh-oh. Did I hate RFL? Yeah, I mean, I think I hated it early on because it felt like it was really obvious. That's obviously the same. I don't mind saying it as a triumphant thing at the end of a level. We're done here. It's like QED. Don't mind at the end. If your proof is just QED, then I'm a bit. This help text is so wise that I need to scroll. Macro. Oh no, there's one of those backtick things. Do I even know how to type those? Okay, I hope I don't have to do this. Tactic vertical bar. And there's a definition of what it's supposed to do, which is the thing we just did. So it's packaged it up nicely into just a kind of shorthand. I wonder if you can put like multiple things inside a tactic. I expect you probably can, like multiple lines of tactics, but I would like to refer to this as squirrels. Hang on. Let's see if I can copy. See if I can copy this. Tactic. And there's one of these. And then, oh my goodness, okay, so I've got to go, and then tactic. And then put the word I'm not allowed to say. And then, maybe I'll type out the full thing, so that it's actually useful for this level. I refuse to use yours. I will create my own using this very wide help field. And what's the syntax at the end there? Close the square bracket, close the round bracket, close another round bracket. Will you let me define a macro? Maybe not. I don't really know what happened. It says no goals left. You solved the level with warnings or a passing error. I'm going to have to quickly check this. I'm a bit disappointed. I was hoping I would get to deploy the squirrels. You can make your own tactics. This should have worked, right? I don't think it should have run anything. Can I make a more stupid thing that's just... No, it's not happy with me. It's not happy. Oh, because I've still got syntax errors in here. That's not how you do that. You have to do it like that, don't you? Yeah, it's not happy. Okay. I'll play along while I do this. Closing apostrophe? No way! This doesn't have a closing apostrophe. Where am I supposed to put a closing apostrophe? After here? Theirs only has like one back tick? What's an apostrophe? Yeah, it's really not happy with me. What about if my tactic is just RFL? Is it happy with me if I do this? No? This is no longer attempting to make progress on the level. Right, fine, okay. I'll do the thing. If anybody who's played before knows whether creating macros is ever an actual strategy in the game, then that'd be good. Because I would like to be able to do that, I think. Pred suck. Oh god, I should stop reading them out. Doesn't allow macros. Yeah. Okay. That's a shame. I was going to make my own macros with better names that are easier to remember and legal to say on stream. Addition more efficiently. Yes, I remember doing a lot of addition. This is very this feels like advanced addition, which was the other branch. So maybe it's one of those votes where it doesn't matter. Let's define a new function, Pred. I've just realised my microphone is miles away. Sorry, headphone users. There you go, microphone. You can join in as well. I should probably have muted while I was doing that. A new function, Pred, from the naturals to the naturals, which attempts to subtract one. It's muddying the water a little bit, isn't it? Yeah, sorry, Eb. Accidental AMSR. Yeah. Definition is this. What is this? What is this? What is this? It's returning a junk value, 37. I hope that doesn't matter. Okay. Like a predecessor instead of a successor. That's going to prove suckinge. Not sure about this. It's what we're replacing it with. The new version doesn't teach. And then you put colon equal sign question mark, which I think might be an emoji. Yeah, it's one of those emotes, isn't it? Feels like it could be an emote. Maybe with just one question mark. Yeah, that feels like an emote. It's quite hard to type because it tries to autocomplete in Twitch. Yeah. It's so confused. My face is a question mark. What am I doing? We've got the Pred thing. We're also going to apply it leftwards. Yeah, you meant the kind of definitional thing, right? We've got this. We haven't been told what it is, right? But this is like defining some function or something. Hasn't happened. Maybe it happened somewhere else. Have something colon equals something. We've already used extensively about that justification. That is kind of what axioms are a bit like, isn't it? Okay, so we're going to do. They're telling me to do some rewriting. Left, Pred, suck, A. I don't really want to. I think I want to rewrite at H. I think that makes more sense to me. Well, that failed. So fine, I'll play along. Okay, what's that done? Why is it taking the argument A? It's done something on both sides. No, where's my gold? It's changed this A. Oh, goodness me. Right to left. We've applied it right to left, so it's taken this N. I feel very nervous about the way that applying it right to left. How does it know if it sees the 37? How does it know whether to apply the first line or the second line? If you're doing it right to left, I don't know. But in this case, it's chosen to write Pred suck A, so that's good. I'm really scared of this 37 and the idea of applying things this way around. I don't understand what I'm doing. Welcome back to the stream. It's Chill Math Sunday. I don't know what I'm doing. I'm just following the thing on here, right? What's our assumption? Let's rewrite it with H and see what happens. Do we know anything about this? I don't know. What's this? Oh, good. This is a proof that we can do the thing. It wants square brackets around rewrite. There we go. RFL. Very nervous about this. Nice, you've proved suckinge. Have I? I think I tried to use it, didn't I? Oh my goodness. Okay. This was suck-ing, was it? Where you create the pred thing. It came out of nowhere. And there's a separate axiom that instead you say pred suck. Actually, it's this way round. It's not the true that pred suck n is n. No, sorry. Pred suck n is true. I don't think we're going to get suck pred because I'm nervous that the successor of pred of 0 is 38, which is not the same as 0. I really don't like that 37. Right, good, okay. We define a function is 0 thus. And it's got those colons and equals in that Neutrino's telling me about. Is 0... Okay, if you see a suck n, then it's no, it's false, that's not 0. If you see a 0, that's 0. Good. 2 lemmas. Is 0 0 and is 0 suck n? Ooh, don't like that. Chat, does 0 suck? Tell me honestly, right? Oh, we've got a new thing called triv. Alright, let's read on. Okay, is 0 0 true? And is 0 suck n false? Okay. You use these to prove that successor not 0, that suck a is not 0, which is an implication. Peano's last axiom. I didn't know they were. I've never heard it called. I've never heard one of them called last. Actually, we've been using 0 knee suck before. Oh goodness, suck knee 0. Suck knee suck is coming along as well. Right, we're currently proving suck knee 0. Yep, we're about to prove suck knee 0. Let's go. Let's go. You can cheat here by using 0 knee suck. But the point of this world is to show you how to prove you can cheat. Oh, speedrun technology. If you can turn your goal into true, then the triv tactic. So it's introducing quite a lot of things all at once here. Triv feels to me like it's going to be... Oh, yeah. That's got the same feel to me as RFL, right? I mean, it's totally logically distinct, but yeah. Sim cheat. Ooh, sim cheat. Ooh. Okay. Right, we're going to intro H. I feel like we're learning a lot of things, and then we haven't really been given very much space to use them in the way that we did a couple of weeks ago. I have opinions about this in video games, which feels weird. You didn't come here for video game opinions, so I'll try and avoid that. What on earth am I doing? Ah, right. I want to use the... Do I want to use induction? No, that's mad. I think I want to use is 0 suck somehow, which is a theorem. Is 0 suck a? It's a proof of. It's a proof of is 0 suck a. What is this? What is this? But I haven't got any truths. I've got the number 0. What is going on? Oh, well, let's read this. Intro H, right? We got an assumption, suck A is 0, and our goal is false. Right. Yeah, because this was just another notation for an implication. Change that false into true. Start by changing it into is 0 suck A by executing rewrite, reading right to left, a new thing that I've never seen before with the parameter A. What? Oh, now the goal is to prove is 0 suck A. Because this is a proof that is 0 suck A. It's a proof of this. So we're rewriting it. Oh, we see the false and replace it with is 0 suck A? Which reads like a question, but is actually a statement. The acrobatics that I'm trying to do, mental gymnastics that I'm trying to do to pass what the objects are. We've done some rewriting. We did it from right to left on the gold, because there's no at statement. We're doing it right to left, and we're using this thing with the parameter A. This thing with the parameter A, from left to right, says that the expression or clause or statement or something is 0 suck A is equal to false. Like it's equal to false. So we can, right, okay, go backwards. Okay, so now we've got is 0 suck A. I have no idea if 0 is suck A. I feel like it's not. I sort of thought that was the point. I haven't used H yet. So this is always me. We do an induction or an implication or something, and I always forget to use the assumption. Let's go. So let's rewrite this using H, which will replace the left-hand side with the right-hand side of H. So we've now got is 0, 0. And now we just want this. We want to use this. We want to write it by rewriting it by is 0, 0. And now the goal is true. And the new thing, the new text, not RFL, we type triv. I feel like that's trivially true. Okay, right, cool. We've now got some stuff. See if you can take it from here. Putting the parameter in front, suck A as 0. Yeah, the sentence, the English sentence would put the subject somewhere not at the end. Is this German? I've just remembered that we're on a German website. How does subject order work in German? Do you get an advantage on this game if you're used to putting the like inputs or subjects? Let's Google Translate. Google Translate English to German. Wait. Do I want German to English or English to German? I kind of want it right to left. There we go. Is 0 the successor of A? Wait, hang on. When I wrote it, what do we want? I want is A the successor of 0. Ist ein Nachfolger von 0? I was hoping A would maybe appear at the end of the sentence and it would be more sense. Okay, right. We did the level 7. Let's go. We're also learning German. Oh, look at all this help. I just said you take it from here, and now look at all this help. 1, 2, 3, 4, 5, 6. Reading. Here we begin to develop an algorithm which, given two naturals A and B, returns the answer does A or B. Okay, good. Here's the algorithm. First note that either A and B are numbers, and hence either 0 or successors. And there are 3 things we're going to do. If A and B are both 0, return yes. If one is 0 and the other is suck n. 0 is not suck n. Whoa, I'm suspicious. Return no. If A is suck m and B is suck n, then return does m equal n. I'll subtract 1 from both sides in a way. Okay. Our job is to prove this algorithm always gives the correct answer. The proof that 0 equals 0 is RFL. Not going to let me type it, but yeah. The proof that 0 is not suck n is 0 ni suck n. And the proof that suck m is not 0 is suck ni 0 m. There's a sim thing going on. The proof that if... Oh gosh, here we go. The proof that if... Assumption. M is n, then suck m is suck n, is rewrite h. Rewrite using h, and then RFL. This level is proof that one remaining job we have to do. If A is not B, then the successor of A is not the successor of B. Ooh, Desmos in chat. I'll have a look in a second. Start with contrapose exclamation mark. What? Oh, right, okay, the contraposition, right? I read all of this, and then you want me to just type contrapose exclamation mark. What is this? Oh, is the right? So it's we had an implication A statement P implies statement Q. The contrapositive is not Q implies not P. I think. Contrapose with an exclamation mark. Hypothesis C equals D and goal A equals B. Not both, right? So what is our assumption? Yeah, there's a negate symbol in chat. What a useful emotes. Okay, I can see some not equals to. But these look like just the things like. Oh no. No, this is contraposed. Oh my goodness. It's affected the hypothesis and the goal. It has in fact chased the negate signs in both of them and solved them. What a fun tactic. Our goal is to show that M is N. And that is something like suck-inge, right? I can't remember how suck-inge works. It's an implication, so I'm going to apply suck-inge at H. Ha 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 ha. And then I can't remember how you do this. That's my goal. My goal's the same as one of my assumptions. Is that just triv? No, it's exact H. Yes! Syntax. Thank you, chat. That's chat. Chat frantically typing the other sort of this is obvious. We've got 3 now. We've got RFL for yep, that's in quality both sides the same. Not true here, M and N. They don't look the same. Triv is when the goal is just true, but it's the other one, exact, that I'd forgotten about. 3rd time lucky. Okay. Implementing it looks like this. And then there's an instance. Chat, I'll level with you. I don't know how much of that I'm going to read. It's got a symbol that I can't type. Yep, cool. Okay, cases, lovely. This lean code is a formally verified algorithm for deciding equality between 2 naturals. I've typed it in already behind the scenes. Speedrun technology. Speedrun technology. Somebody else has typed it for me. Because the algorithm is formally verified to be correct, we can use it in lean proofs. You can just tell it to decide. The word decide doesn't appear anywhere here. Attempt to solve a problem, it can find an algorithm which it can run to solve it. A term is of type. Stressful. The end is just nat. Can I type those? Ah! Ah! Ooh. Ooh, it's got integral signs as well. Oh, this is brilliant. Great, cool technology. Right, so apparently I'm just supposed to type the word decide. Level complete! Some of the levels are kind of technically a game. You can read more about decide by looking up here. Yeah, I wish Twitch chat had this, right? And I tried to put it in Twitch chat. We tried to set up emotes where you could have these, but wouldn't allow it. Is the nicer one just decide? Right, great. Who voted for Algorithm World? We've done it. I hope you're happy. Level 8, I've written it behind the scenes. You just have to type decide. Level 9, boss fight. Don't forget to hydrate, chat. Especially if you're feeling under the weather at behind the scenes. Sorry, that's the best thing I've ever seen in a video game. You'll decide if it can find an algorithm. Right, good. Okay. I already thought this one was a bit overpowered in that it would just have a go at doing the level for me. This one seems really good. The algorithms will be helpful for you in even odd world. Not a thing. Maybe it's coming later. Yeah. Okay. Did version 3 have an even odd world? Can I write decide as a proof in my maths exams? I mean, if your maths exam is prove that 2 plus 2 is not 5, I mean, still no, right? Sometimes these puzzle games that you play, we're going to do the other worlds, don't worry. Sometimes these puzzle games, and I'm not sure I class this as a puzzle game, so this is not criticism of the natural number game really, but sometimes puzzle games introduce mechanics. I feel they introduce mechanics sort of too fast. This bit you're just mastering a mechanic. You're like, oh, I'm really understanding the nuance of like the portal goes over here, or I push the block and now it spells a different sentence. Like, you're just getting it, and then they bring in a new mechanic that sort of sometimes, not really in Portal or Barrows U, but sometimes in other games can feel a bit like they just ran out of ideas or ways to use the technology, which is not the case here. We've got all of mathematics to do. Good. They're both OP. Should we do some advanced addition? I've unlocked decide now by doing the worlds in this order. Fast pace. Should I try speed running? Should we try a quick review on what's going on here? Oh no, I didn't enjoy that. I didn't enjoy this at all. No, quickly remembered I didn't like this. But I've unlocked decides now. Does decides just do all of these? No, not really. Okay, good. Oh, now it's marked as incomplete. Whoops. Chat, for completeness, I'm just going to quickly do this level again. Oh, I don't like this version. Hang on, wait. Sorry, I deleted my progress on one level only. I'm gonna. I don't want the thing to be a different colour. Ah. Ah. Oh my goodness. Oh, I've broken things. I've broken things badly. I've got no goals left. Solve the levels of problems. It's having real issues. Oh, it didn't like this. It didn't like this. Back up, back up. There we go. That's a good revision, actually. RFL. Good, we revised it. Whew, fixed the blob. The blob went back to blue, which is very stressful. Advanced addition, let's go. I think I want to keep doing natural number game. I'm nervous to do graph or cold. Oh, I do want to look at your Desmos though. Let's look at your Desmos. Yep. Did you see? I didn't realise you'd see that. You can see me take it from chat and take the link. Ah, oh, brilliant. Okay. These are very good curves in Desmos. Thank you for the submission. So this red one is... Ooh. Oh, so these are ways you've found for dodging things. What is this blue one? I think we saw that one before. This green one is for going round bullets that go around corners or around obstacles. Very nice, I like the square. And then the blue one you put sign on top, which is just bonkers. Look at that. I guess that the exponential is damping it down over here. And then you get sign over here because the exponential has become like 0. So this is like sign divided by 1. That's pretty cool. Right, good. Okay. I'm going to do advanced addition. going to use to build theory of inequalities. I kind of just want to see the inequalities. I think they might start to resemble stuff that you do very carefully for stuff that I've seen people get wrong in real maths problems to do with inequalities. That's out there. But first, basic addition facts such as this implies y equals 0. That's nice. Okay. I wonder what we're going to use. In this one, I'll mostly leave you on your own. The tutorials. Oh wait, no. Here's another tutorial. Add, right, cancel a, b, n. It's the theorem that you can cancel off n from the right hand side. Oh, okay. Ugh, it's got an implication in it. The theorem that implies that, but that is. Oh, we're trying to prove it. I don't have it yet. This thing here, not unlocked yet. Okay, so right, okay. Thanks, chat. Intro H. I kind of want to induct on n. Is that mad? No, I'm going to do it. We did a lot of induction before. I'm going to do some induction again. I can't remember. Induction on n. Let's go. Assumptions. A plus 0 equals b plus 0. Goal, a equals b. I can do that. Rewrite and 0. Repeatedly do that at h. Good. And then that's exactly h. Is this mad? It feels a bit mad. Oh, I'm not looking forward to proving this one. My assumption is that implies a equals b. My goal is a equals b. I've got this, so I'm going to rewrite h. Oh, I want to do something like at h to move those over there. And have I got the pred thing going on to say? Oh, no, this is suck inge. But I think I'm going to get this comically wrong. No, we're good. We're good. And then I want to apply HD at H. Yeah, and now it's going to be exactly H. Nice. Whoa. Oh, you wanted me to rewrite HD? I was rewriting H. I think there's a forwards backwards thing going on as well. Maybe adding 1 to both sides would have been... Yeah. Maybe? I'm not really sure how rewriting HD works. Induction is good for the natural numbers. It's kind of what the natural numbers are. Okay, add left cancel. You can prove it by induction, or what I'd like to do is just use the fact that add is commutative. So let's intro H, and let's rewrite H. Let's rewrite H using. You got to be a bit careful with addcom, right? Because you can go to an infinite loop. NA at H. Let's rewrite addcom NB at H to flip that one around as well, and then let's apply. So if I just apply add right cancel, so I'm doing it the other way around, instead of doing it at H to do it to the goal, then it'll change. Ooh, question marks. I don't know what I thought was going to go on there. We've got question marks in front of the ends. Hey, is that exactly H? Oh, it is. Why are there question marks? Synthetic hole. Okay. Sorry I asked. Maybe I would have been happier if I'd done. Let's back it up. Back it up. Nope. Back it up to here. Yeah, and that would have been a bit more friendly. Forwards. I didn't name the variable. Ah. Okay. Is that type? No, it's a sort of dagger. Okay. Sort of dagger shape in there. A forced to assign a variable for something, it does this. Okay. Okay. Okay, I think I want to prove most of these by induction, to be honest. So we're level 3 out of 6. Add left equation self xy. Then maybe the names matter, so it's neutrino. X plus y, xy implies x equals 0. That's what we're going to try and prove. Okay, so when we've got these implications, I think I find it helpful to introduce it with a hypothesis kind of thing. So we get the kind of hypothesis and the goal. Goal is a statement because, you know, that makes me feel happier. And then I suppose I think I want to induct on y. Because if that's 0, then I've got a nice way through, and otherwise I'm just going to add 1 to both sides each time. So I'm going to do induction so it's induction on n with DHD. No, I don't have an n. I'm in y. Good. So this one is add 0. So we can use add 0 at h, and that'll change that around, and then that's exactly h, and then that's the intermediate goal. The other one we've got, oh my goodness, so we know HD. Oh, because I've used add right cancel. Oh yeah, the thing we were just doing. Back it up, back, yeah. That's a clever enough thing to say, but yeah. There's an adding. Right, what's add right cancel? I thought it was clever. I mean, I can make this into a... Yeah, so I could rewrite that y on the right hand side. Oh, I don't know how I'm going to rewrite that. Yeah, I want to rewrite that second y to be a 0 plus y. 0 add, yeah. But I have to do a very targeted rewrite using some of this, right? There's something in here where you can target it. Targeted usage. Oh my goodness. Only want to change, last sentence, only want to change this. You do nth rewrite. This feels clever. Nth rewrite. Second, I want to do using, oh my goodness. Oh, it's not, maybe this will work, I'm not really sure. Yeah, I want to add 0 to the y. I want to use 0 add, I think left y. Yes, that actually worked. That actually worked. What do we do with add right cancel? Is it a sort of apply sort of thing, or a sort of rewrite kind of thing? It's one of these. Oh. Good team effort there. I start doing something stupid. Chat tells me use the previous thing we were just doing, and then we work out how to do it, and then it's a targeted nth rewrite with a right to left version of a thing we haven't seen for 2 weeks with a variable in it to make sure it hits a 0 plus right here. That's very nice. Welcome to speedrunning. Well, I mean, allowing for all the time it took me to look this up. If we're doing a speedrun, it's not happening right now. Wait, what's this? What is... How dare this tutorial... How dare this tutorial tell me to do it the way that chat told me to do it as well? Did you use induction on Y? I almost did. But this took some looking. This was work. Why does this say exact? Oh, we had this. We had this before. Oh, 0. Ooh, okay. I'll just apply. Apply and let it do its own thing. Right. I'll mention them when you've solved it. Ooh. Ooh. Well, I could put a 0 on the right hand side, right? This is sort of the same thing. And the other one's probably induction or something. Add 0 with the parameter x. But we're going to do the nth rewrite to do it to the second one. And then use the left cancel thing. Have we got left cancel now? We need to apply add left cancel. So it's the same but symmetrically the other way around, and we've got, you know, our strategy from before is so good that this is going to work here. What do they say? Here's a proof using add left x self. Oh, right, okay. Intro h. Okay, none of these ideas look like what we did. Brilliant. Okay, speed run. It's also easy to remember because it's the previous level, but with add 0 the other way around, and with left instead of right. You need to speed running to be easy to remember, if you're me. Next result we're going to need new tactic, cases. One of these factors in the level and the other in the next. Cases tactic splits an object. Possible ways that it could have been created are we've seen a bunch of times doing things separately for 0 and for successors. Yeah, okay, right. You don't need the inductive hypothesis HT that comes with induction B with DHD. Nerfed induction, okay. You don't need the inductive thing. So if you are about to do some induction, you think, wait, no. Tie this hand behind my back. I don't need the inductive hypothesis. 2 ways to make a number 0 successor. If you have the hypothesis false, then you are done. There are no ways to make a proof of false. This sounds very dangerous, but fine. We are playing the natural numbers game. Here we want to deal with the cases B equals 0, B not 0 separately. So start with cases B with D. No, let's do it properly. Cases B with D? It's like with D thing going on. And that's giving me an active goal. I can't see that I had a D yet. I think it's coming over here for our second goal. This first one looks like add 0 to me. Yeah, and then that's just. Oh, how do we prove a thing implies thing? Is that? No, I can't remember what this is. Triv. No. Reflects. It's self thingy. It was the first thing we did in implication world. Thing implies thing. It's one of these. Yeah, no, I've forgotten how to prove thing implies thing. Oh yeah, you intro H, and then it's RFL. Okay. No, it's exact H. Right. Okay, we're on to the second goal. If A plus the successor of D is 0, then A is 0. Okay, and this is just false, right? Because D is not. We're going to write it as. Yes, we're going to rewrite the suck to the left, which is add suck. Yep, and then 0 is not suck. So we're going to apply. Oh, it might be suck knee 0. It was a false thing. Yeah, so this is just somehow false. Pliers backwards. I don't know what that means. Do I use exact to go forwards? No, I've completely forgotten everything. Somehow, I've completely forgotten everything. It's not even happy now. It doesn't even know what suck knee 0 is anymore. Do I apply it? I haven't got a hypothesis. Oh, I got confused. I'm going to intro H. If I already introed H, I don't think I have. Oh, I'm going to intro an H over here as well. Good. Okay, I've got an H. Phew. Apply suck knee 0 at H. Oops, just says it. Oops. I'm not having a good time here. I would like to use the fact that this is not true. So this is a proof that suck A is not 0, which means suck A equals 0 implies false. So I would like to apply suck knee 0 with parameter A plus D at H. It just says oops. Neutrino would like to contrapose. Fine, let's contrapose it. Let's rotate the board. Yeah, no, it's not happy. It's not happy in a different way. Mathlib tactic contrapose.mgr question mark m.191. If you have a hypothesis H colon false, and this feels false because the successor of things is not 0. I thought that's what this was. Is it this one? I don't think we've got X falso. This feels like the moment where we get really stuck, like last time, right? So okay, I want to convert that into a false thing because why can't I apply the thing that I have? Why can't I apply it? I'm seeing it again, right? This is just exactly what I tried before, and it just says, oops. Let's back it up a little bit. Doesn't like that. This was good, right? Because we proved this first bit, and then we move on to the second bit. I haven't got the spell. The Latin spell. A plus suck D equals 0 implies A equals 0. Let's try contraposing this. Okay, active goal. A not 0 implies A plus suck D not 0. So we could maybe rewrite this with add suck to get that, and then try applying suck knee 0. I know it's saying it doesn't know what suck knee 0 is, right? Unknown identifier. Did I type it wrong? Yeah, I don't know. I no longer know what's going on. Apply suck knee 0 now. Nope, doesn't know what it is. Back up, back in. Restart, do over. Do over. Don't actually think I'm learning about cases right now. This is B with D. So this one's easy because this is just the rewrite with add 0. And then thing implies thing, you split it apart and you exact H it. So now we've got this one again. I've got back exactly where I was. Exactly where I was. So what are the things to do with the false thing, right? Decide. Oh, I didn't like it. Free or meta variables. Didn't have any of those. What is going on? Yeah, still think it's this. And then somehow this is false. Right, so what does this mean? So this means it's like a equals 0 implies false. So if I call it something else, and then apply this is very infuriating. So I'm not going to be able to conclude that a equals 0, right? Because the thing is just false. The assumption is false. It reads successor of a number is 0, which isn't true for any number. Yeah. Maybe I'll do induction instead. This cases thing is quite annoying. Let's try induction. On what are we inducting on? B with DHT. Ah, look. So this thing is the same at start. Oops. And then this is exactly H. And then we move on to the other one, where this looks exactly the same, except we have an assumption that, yeah, we write add comma H. Is that helpful? Oh, I've done H now. You don't need induction either. Oh, this is pro mode. Right, okay, I'll come back to that in a second. I want to see if this is intermediate. If this is easier if I use induction along the way. Gosh, I'm so stuck. Still want to do this, right? I don't want to apply HD and apply HD. No, yeah, this is nonsense. I don't even know what I'm doing. I'm very annoyed that I can't work out how to use suck knee 0. Like, it's just broken, right? That's what I want to do. Neutrino solving this in chat, which is dedication. Intro H, rewrite, add conf. I want to struggle a tiny bit more. The struggling is good for me. It forces me to actually think about and understand what's going on. What's that done? Okay, that H2 is now really cleanly the thing that I want to apply this to. Goodness me. It's not just me, right? Rewrite. Let's try flipping it around. Rewrite sim H2. Oh, come on. I have. It's right here. I've unlocked it. If it did, I did it before. Okay, right. I'm going to do Neutrino's cheat method. Thanks, Neutrino, in advance. Right. Okay, our goal is proof that if a plus b is 0, then a is 0. I guess so is b. You add together two natural numbers, you get 0. They're both 0. Have we already got some sort of add left x0? Neutrino is hinting me to do. Oh my goodness. Add left x self? I haven't been learning the names along the way either. Nope. These are two things I don't have. Well, I'll try doing what Neutrino says, see if you're onto something. Intro H. Rewrite adcom at H. Oops. Brackets. You know, if we had a left thing. If we had a left thing, would be good. I think I've got either yet. And worryingly, it thinks that I don't have sim either. Has it? Maybe it's lost all my progress or something? I don't know. Yeah, definitely think I want cases. Sorry. So this is B with D. Right, goals. So this one's 3, right, add 0. Oh, but this just feels like I'm going around in circles again, doesn't it? Because I'm back here. And I'm going to try all the same things I was about to try. And the suggestion is I use contrapose, so I'll try contraposing here. What's the notation of contrapose? If you have a hypothesis, well, I don't. Let's let the intro H2 and then try contraposing. Oh, come on. I've got a hypothesis. I've got a goal. Oh, contrapose something. Yeah, okay. Okay, that looks like progress. Because maybe Suckney 0 is this. Oh, come on. That's really what Suckney 0 does. Our goal is Suckney 0. Is the successor of this thing is not 0. And success nothing. So nothing. This is 0 is definitely not the successor. Oh, come on. Am I supposed to apply it? Am I supposed to somehow use it? Just state it. Let's just try stating it at chat. Unknown tactic. Exact. I know what it is. It doesn't know. Why doesn't it know? We did this. Yeah, I'm now getting more confident that this is just off. Natural number game. This is definitely this. Try splitting it apart just in case that helps. I like the way we've got these not equal to signs now. Our goal is false. Let's try apply Suckney 0 at H. Oops. I think I'm stuck. I think I might be out. I might be done. Winners never quit. Quitters never win. Let's prove Fermat's last theorem instead. Feels easier right now. Neutrino wanted to try exact. I feel like I will keep trying things that people in chat shout. Neutrino's doing a lot of shouting. Passing error. Passing error. Oh, it's got the previous thing they didn't like. Unknown identifier. It's got a squiggly red line underneath it. I know, it's just though, like, how dare it say that it doesn't know about Suckney 0? Does it want an argument? It just doesn't recognise it. 2 weeks ago we had a lot of trouble where I had to learn that you put brackets around things. This was like a separate issue that this was broken. Just apply at the goal. Just this? Oh, I had the previous thing in as well. Sorry. Yes, it. Still says unknown identifier. Oh, I had it in there twice. Yeah. Probably some sort of syntax issue. Yeah, I think we're applying it wrong. Or let's go back and look at a level where we learned about SUCNI 0. Was it around here somewhere? Yeah, here's some SUCNI 0. Did this have SUCNI 0 in it? No. Previous. Next. I don't know, it's here because I've unlocked it. 0 NISUC. At age. Exact age. Close to false thing. I agree with Neutrino, by the way. 2 weeks ago I felt like I didn't understand what's going on. This time I feel like I do understand, and the thing we've typed should match up. Hi Johnny Depper, Twitch. Wait no, Joni Depper 2, Twitch. Welcome to Twitch. Thanks for the follow. You followed at a time of great crisis. Between us and Inequality's world is the fact that we cannot apply SUCNI 0 because it is an unknown identifier. I fear that this may be broken. Hi in chat. Some people in chat are also playing Graph War, if you want to join in with them. They'll explain it to you in chat if you ask. It's a Steam game that's free and you fight like in Worms, but using graphs. I think I'm probably going to play it on stream at some point, but I'm not brave enough to without practicing first. Which brings me to this thing which I'm struggling with because... So at some point do we prove that SUCNI 0 is true? I think at some point we proved SUCNI 0, right? I can't remember how, possibly by like induction or something mad. Don't really want to, but it feels like SUCNI 0 is broken right now, and we should prove it. I'm a little bit worried. There was this really confusing sequence where 0 NISUC. Piano's last axiom. Okay, so one idea is to try and spin it and use 0 NISUC. Graph War the game seems like the better you are at building functions, the better you are at the game. So let's try and rewrite. Oh no, it also told us we didn't know sim, right? You do straight lines. Guess the coefficient. Yeah, let's do that instead. Go on. 10 minutes. I don't know what I'm doing wrong, but the idea that I'm not allowed to use sim and I'm not allowed to use SUCNI 0 makes me feel like it's just broken. Right, in a new, let's try streaming a game. How do I actually do this? Oh, do I need to install this? Yeah, I haven't installed it. Okay, we're not doing this today. At some point, win ratio of 0. At some point, I'll install Graph War, work out how to get it going. You probably don't want to see me learning how to open an executable on stream. I think that means I'm calling it here. Disappointing. Story of my day. I'm feeling a bit under the weather. I think the natural normal game might be feeling a bit under the weather as well. Unknown identifier, SUCNI 0. The feeling when the interpreter is maybe just as confused as me. Right, what's happening this week? So I think I'll see some of you next week for goodness knows what. This week on the stream, on the work stream on Thursday, we're doing something that I'm a bit worried about, because it is also quite foundational, and it's not a sort of maths that I've talked about before. So Thursday's stream could go one of two ways. It could be new and exciting, never seen before, or it could be a total car crash. We're going to find out at work, live. Maybe at some point we'll come back to the natural number game and see if we can get past this level. Maybe we'll try version 3, which has different content and explains colon equals. I think next week we might go back to learning maths or something. One of my New Year's resolutions is to learn integration. Take care. Try sim. Yeah, so a cool person I wanted to try sim, but just to show you where we're at right now. So sim, the syntax is to rewrite sim at h, and it tells me that I haven't unlocked sim yet, which is false. I have unlocked sim. I did level for sim. So this is the more evidence that I think. Not totally with it. The questions I had answered were marked as done, but when I clicked on them, the solutions didn't work. Is the website down? Is something like seriously broken? Unsolved goals. Oh, no, the website's still up. That's good. You can still RFL. Okay, right, cool. I'm calling it. Sorry to cheating you out of 10 minutes of your life. No, wait, I'm giving you back 10 minutes of your life. Good times. Take care. See you next week. Have a nice one. Bye.